Welcome, friends, to this series of learning containers and Kubernetes. So in this particular lecture, we are going to see how we can deploy a production scale web application. In the earlier lecture, we saw how we can create the subnets and how we can assign a subnetwork within a CIDR range. And we created the containers within that subnet range. And also we created the private network. So in that private network, whatever container is running within that private network, it was not being accessible from the external world. So it was actually a secured layer which can be assured to provide the secure communication within the network. If you have not yet watched that video, you can watch it right now. We are providing the links of those videos in the description below. Now, in this particular lecture, we will see how we can create a database in a private network called PrivNet. And this particular network, we will have one container and we will run the database inside this container. We will run a MySQL container inside this private network. And this particular database will map its volume in its host machine so that the container will not lose the data. Even if the container dies or anything happens to this container, we will be assured that there will be no data loss. Now, this particular database is not accessible to the outside world, so no user can access this database. But we will create another network, which is MyNet, which is completely accessible through 8080 port from external world. And this particular container, this particular web application will be running on this container, which is in MyNet, and also will be connected to this private network from where it can communicate with this database. So this particular database can be accessible through this web application, but this web application only can be accessed by this user, but no one can reach to this database, so that we can secure our database in a private network. So let's jump to the console and we will see how we can implement this particular solution in our production system. So friends, this is our Docker VM where we had run our previous containers. So we had run the MySQL server in a private network, and we also created some Nginx sub that is in the sub network. So right now we are going to clean up all these things. We are going to clean whatever the Docker containers we created, and also we will remove all the networks that we have created in the last lecture so that we can try to build everything from the scratch. So if you run this command docker ps -a, and then if you want to remove the first line from these results, so you can say grep -v container, and then if you want to print the first column, which is the container ID, you can use the awk command in Linux, and it will print you only the container ID. So if you say docker rm -f, and then you provide the sign of $, and in parentheses you run the entire command, it will actually start to delete all the containers from your system. So if you once again check this ps -a, you can find there is no Docker images or Docker containers. You will find there is no Docker containers in the system anymore. And similarly, if you check Docker network ls, you will find we created this my host and privnet bridge connections. So maybe we can drop these networks as well. So Docker network RM and my host and privnet, it will delete the networks as well. Fine. Now try to connect, let's now try to create the network, a private network. So network create -d, and we can say it's as bridge network. We have no issue. And if we say minus minus subnet, then we can specify the subnet as 10.2.0.0/16. And that is how we can provide the subnet. And within that range, all the IP will be assigned to these containers. So that's one. And also we will specify internal to make it an internal private network. And we can name the network as PrivNet. Obviously, we need to specify Docker and our network is created. Now we can find that our network, and we can see our private network is ready. And if we want to see Docker network inspect private net, then we can find that this particular net is the internal network and the subnet is assigned as expected. Now let's create one network called MyNet, and we will create it very simple. Docker network create -d bridge and then MyNet. And now let's run one MySQL server inside this private net. So let me clear the screen first, and let me provide this command docker run -d, which is running the which will run the container in background. And we are specifying the root user ID as root123, and we are specifying this user1 -e, and password network is private network, and we are naming this server as MySQL server, and we are mapping this volume to data var lib MySQL, and we are assigning this IP. Now see, this particular IP 10.2.0.2 is actually within the subnet. If you scroll up, you can find that this is inside the CIDR range. So this is just this one. Now here I will specify one more environment variable, that is the database name, which is passed by -e, and the database name I will say testdb. Okay. And then this particular container will run, and this particular container will run the MySQL database in a private mode. Okay. Now, so let's create a new container from Python image. So this particular Python image is provided by Docker Hub, and we are going to create it within this MyNet. MyNet is basically the network that is accessible from the external world. So though this particular MySQL server is created within this network private net, which is not accessible from the outside world, but this particular Python container will be accessible from the outside world. And we are mapping these 5000 port to 8080, because this is the 8080 port from where the external user will connect to this container as per our architecture. Okay. Now, this particular Python is not available in our local image repository. So it is trying to pull this image from Docker Hub, because we did not create this Python before in this machine. So now it has already downloaded this image from Docker Hub and it started to run the container. So if we say Docker PS, we can see MySQL Server, which is running within private net, and this Python 4 container is running on host 8080 port mapped with host 8080 port within its 5000 port. Okay, so now this particular container Python 4 cannot reach to this MySQL server because they are in separate network. Now, what we will do, we will actually use a Docker network connect command to actually connect to this Python with this MySQL servers network, which is private network. So what we will use Docker network connect and then private network with Python 4. Now this will actually bridge the connections between these two containers so that Python 4 can be also the part of this private net, and also it can access this MySQL server through private net. So if we say Docker inspect Python 4, we will see there are two networks assigned to it. So the network portion, it is saying that it is a part of this MyNet, which is accessible from outside world. Also, it is the part of this private network, and it also assigns some IP address from the subnet range that we provided in this private net. Now, right now, our Python code is a Python container can reach to this MySQL server. Now, let's go to this Python 4 container. We can use Docker exec -ti Python 4 bin bash, and now we are inside the container of Python 4. Now, right now, what we will do, we will create one directory inside the container called /app. Now, whatever our code we will write, that will be inside this /app. Now, let us exit from this container now, and let me show you. We have write one code that is app.py, and if we can show you, this app.py is a very simple Python code which is basically import the MySQL connector, and it is also using the Streamlit and Pandas library. And what it is trying to do, it is just use the Streamlit to take two inputs from those text input box, and you are just going to provide the serials, item serials, and item details, and it is going to try to make one connection, and this is our connection. This is the host of our database container. You can find this container's address as I showed you before. It's 10.2.0.2, and this particular IP address you have to provide to make the connection as host, and we did not specify any port, so 3306 is the default port, and also we are using this root and root 123 connection to make the connections from the MySQL server. Now, here is the button. We have one button, insert item. So once we click this insert item button, it will make the connection, and it will try to use this test DB, and it will create the table if the table is not existing, and then it will insert the data, whatever you have put in from these text boxes. So it will just input those data, and then there will be another button called show items. Once you click this show item button, then it will try to execute select asterisk from this table test, which you created in the earlier step, and you created and you inserted the data inside the test table. So once you click this show item, you can see the all data from this test table. So it's a very simple web application, and finally it will use the Panda data frames to print the data in tabular form. Now, we are going to copy this particular program inside our Python container inside the slash app directory. So Docker CP requirement.txt, we are going to copy this one, and as well as this app.py, we need to copy to this app directory. So what is there in requirement.txt? Requirement.txt is basically containing the libraries that we need to install inside our Python Docker container. So let's go to this Python Docker container once again, and let us try to install our requirements from requirement.txt. So let's uh, install this one. So the command is pip install -r, and this requirement.txt file we just copied. So let us start installing all these packages those are needed to run this particular web application. And it is done. So I did not have to pause my video. Now everything is done. Now what we will do, we will just run this application through NoHub, and we can say streamlit run app.py, and we are specifying this server to run from 5000 port from container. Now you can remember that we map this 5000 port of this Python container to our 8080 port of our host when we started this container. So if we do so, it started to run. And if we check the content of this nohub.out, we can find this is the IP address, and 5000 port is given. We will not use this one because it is inside the container. So I just showed you for your interest, but we will try to access this application from our main host's IP address. And as I said, this 5000 port, as it is running from 5000, as we specify the server port is 5000, it already started this application from 5000 port inside the container. But as it is mapped with 8080 port, we can access this from host's 8080 port. Now let's jump to the browser and try to access this container web application that is running inside the container. Now let me grab this external IP of the host, and let me go to this browser, and let me provide this IP address and then 8080 port. And if we do so, we can see our container application, the Python application is running very fine. It's running very well. Now, here we can provide the item serial and item details. Maybe I can specify item serial number is 1. And if I say the item is book, and if I press insert item, it will show that item 1 inserted successfully. So this is where our insert statement worked. So that means our database were connected successfully from our Python application. And if we press show items, it will show the items 1 book. Maybe we can try to say item 2 book. Maybe we can say pen, and we can insert the second item, and we can click show item, and it shows the 2 items from the list. Now, this is successfully inserted the data inside the database, and also it can able to fetch the data from the database as well. So we saw how we can create a database inside a private network which is not accessible from the outside world, but the Python application we can run in some network which is accessible from outside world, but it can successfully try to fetch the data and insert the data into the database which is in a private network. So in this way, we created a very secured multi-tier application and we segregated the database from the web application. And we can run this in a production system so that our database is kept secured without touching it from the external world, and as well as our main container web application can run and can be exposed to external world without compromising any security concerns. So thanks for watching this video. We hope that you enjoyed a lot in this particular video, and in the upcoming lecture, we will deep dive into different things in containers and Kubernetes. Thanks for watching this video and see you in the next lecture. Thank you. Bye.